Next, I'm going to ask the people in the front row to each give me a one-digit number, and any number from 1 to 9. Say a number. 7. 3. 8. 4. 7384. Now when I hear the number 7384, I can think of 4 different multiplication problems that we can do with it. We could do 7 times 3 times 8 times 4 to get 672. Or we could do 7 times 384 to get 2688. Or we could do 738 times 4 to get 2952. And last but not least, we could do 73 times 84. That would be 6,132. Now it's time to talk about my favorite arithmetical operation, multiplication. As a kid, I enjoyed multiplication so much and spent so much time thinking about it that I was tempted to call this lecture The Products of a Misspent Youth. Once you've mastered your multiplication table up through 10, you can multiply any 2 one-digit numbers together. Our next step will be to multiply 2-digit and 3-digit numbers by 1-digit numbers. We call these problems 2-by-1s and 3-by-1s. As we'll see, 2-by-1s and 3-by-1s are the essential building blocks to all mental multiplication problems. Once we've mastered those skills, we can move on to multiplying any 2-digit numbers. In fact, we'll see at the end of this lecture that many 2-digit multiplication problems can be turned into 2-by-1 or 3-by-1 problems. We know how to multiply 1-digit numbers by numbers below 20, so let's do some bigger problems. We'll start with a very, very simple 2-by-1, 20 times 7, or equivalently, 7 times 20. So, we start by doing 7 times 2, which is 14, so we instantly get 7 times 20 is 140. That was just a warm-up problem. All right, now let's try a more complicated one. Let's try the problem 23 times 7. All right, we start with 7 times 20, which is 140. Then we do 7 times 3, which is 21. Add those together, 140 plus 21, and we get, from left to right, 161. Okay, let's try another one. Let's try 87 times 8. We start with 8 times 80. Well, 8 times 8 is 64, so 8 times 80 is 640. Good. Then we do 8 times 7, which is 56. Now we add them together from left to right. 640 plus 56, that's 600 and what? 40 plus 56 is 96, and there's your answer, 696. Now, what we've drawn here looks like what we do on paper, but it's a little different in that here we see the bigger number first. Here, let's do a few more problems. I'll start with one that I think is especially easy. Let's do 53 times 6. Okay, so 6 times 50 is what? 300. In fact, I want you to say it. Say it. 300. The reason we can say it is that the answer is not going to change to 400. There's no way that can happen. Why? Because I'm about to add a 1-digit times 1-digit problem. Those can't get any bigger than 9 times 9, and that's less than 100. So I can say 300 with complete confidence. Next, we'll do 6 times 3, which is 18. Go ahead and say it. And now you've said 318. You've said your answer, 318. Okay, you try 87 times 5. 5 times 80 is 400. You can say the 400, so do it. 5 times 7 is 35. Say it. 435. 35 is your answer. Okay, let's try some harder ones. The next one's a little harder because it has a carry, but it's still not too bad. Let's try the problem 28 times 9. All right, we start with 9 times 20. 9 times 2 is 18, so 9 times 20 is 180. Next we do 9 times 8, which is 72. Now the hard part, 180 plus 72. I know that's going to carry, so I'll start to say 200, then adding 80 plus 72, that's 152. So there's the rest of the answer, 52. 252. Now, it took me about a minute to explain that, but trust me, with just a little practice, you can calculate any 2-digit times 1-digit problem in just a few seconds. Okay, you try this one. Find the area of this triangle. It has a height of 14 inches. It has a base of 59 inches. We know that the area of a triangle has the formula 1/2 base times height. So I have to calculate 1/2 times 59 times 14. But since I can multiply numbers in any order, that's called the commutative law, I'll do 1/2 times 14 times 59, because half of 14 is 7. So the problem simplifies to 7 times 59. Okay, how are we going to do 7 times 59? We'll start with 7 times 50, which is 350. Then 7 times 9, which is 63. 350 plus 63, let's do that from left to right. I see a carry coming. It's going to be 400, and 50 plus 63 is 113. So there's the answer, 413 square inches in our triangle. Here's another way to do the same calculation, 59 times 7, that you might find even easier. Since 59 is 60 minus 1, we could treat this problem as 7 times 60 minus 7 times 1, right? 7 times 60 is 420, and now all I have to do is subtract 7. 420 minus 7 is 413, and that's your answer. Instead of doing a hard addition problem, we did an easy subtraction problem. Here's another problem that can be done 2 ways. Let's try the problem 78 times 4. Using the addition method, we can do that by taking 4 times 70, which is 280, right? 4 times 7 is 28, so 4 times 70 is 280. Then we do 4 times 8, which is 32. 280 plus 32, 28 plus 3 is 31, so I have 312 as my answer. Now let's try and do that problem using the subtraction method. Here we'll treat 78 as 80 minus 2. So we'll do 4 times 80, then subtract 4 times 2. 4 times 80 is 320. Minus 4 times 2, that's 8. 320 minus 8, say the 300 if you will, is 312. And that's your answer. So, which method should you use? At this stage of the game, I recommend that you do it both ways. This way, if you get the same answer both times, you can be pretty certain that the answer is right. Here's how I recommend that you practice. In the beginning, it's very helpful to be able to see the problem. Your goal is to solve the problem in your head without writing anything down. But if you don't have to remember the problem, then that will make it easier on your memory. For example, when you work through the problems in the course guidebook, go ahead and look at the problem as you calculate the answer in your head. But once you're done with those, create problems on your own where you only let yourself see half of the problem. A calculator can come in handy for this. In fact, here's what I do. Let's take the problem 3 times 87. We'll bring out a big calculator. All right, so with the calculator, you might type 3 times 87, but before you hit the equals button, don't do that until you have the answer. Now the calculator is allowing you to see 87, but not 3. Okay? For a greater challenge, you could instead do 87 times 3. Now you can see the 3, but not the 87. Eventually, you'll do the problem without seeing any of the numbers, and don't hit the equals button until you have the answer, 240 plus 21, 261. So why should 3 times 87 be the same as 3 times 80 plus 3 times 7? The short answer is that this is called the distributive law, and the rules of arithmetic are defined to obey this law. But here's a more intuitive explanation. If we have, say, 3 bags of marbles, and each bag has 87 marbles, then how many marbles do we have? Well, by the very definition of multiplication, we have 3 times 87 marbles. But now suppose I tell you that in each bag, 80 of the marbles are blue and 7 of the marbles are crimson. Now how many marbles do I have? The answer is still 3 times 87, but we could also say that the number of blue marbles is 3 times 80, and the number of crimson marbles is 3 times 7, so the total number of marbles is 3 times 80 plus 3 times 7. Which answer is right? They're both right, so they must be equal. 3 times 87 is 3 times 80 plus 3 times 7. Another way to see the distributive law is by drawing a picture. Okay? Look at this rectangle. It has a height of A and a width of B plus C. So what's its area? Well, on the one hand, it's A times B plus C. On the other hand, if we look at the area of one rectangle inside of it, has area A times B, and the other rectangle inside of it has area A times C, so the total area would be A times B plus A times C. Therefore, both quantities are the same. The same logic applies to larger multiplication problems, like 7 times 324. Imagine 7 bags, each containing 300 blue marbles, 20 crimson marbles, and 4 dark green marbles. The total number of marbles is 7 times 324, but it's also equal to 7 times 300 plus 7 times 20 plus 7 times 4, so they must be equal. And on that note, let's start multiplying 3-digit numbers by 1-digit numbers, which I call 3-by-1 multiplication. Naturally, you'll need to be good at doing 2-by-1 problems before you can master 3-by-1 problems. On the other hand, practicing 3-by-1s is a great way to improve your ability to do 2-by-1s, so let's move on. As we'll see, 2-by-1s and 3-by-1s are the building blocks for all mental multiplication problems, so we want to be comfortable with them. Again, we'll start up with a very simple warm-up problem, 300 times 7, or equivalently 7 times 300. All right, so since 7 times 3 is 21, we instantly get 7 times 300 is 2100. Okay, as I said, that was an easy one. Here's another problem that's almost as easy as a 2-by-1. Let's do 320 times 7. Okay, so this time we know that 7 times 300 is still 2100. Next we do 7 times 20, which is 140. Now, I want you to listen to the numbers. 2100 plus 140 is 2240. The word hundred lines things up not so much in your eye, but in your ear. 2100 plus 140 is 2240. Now let's take this one step further. Let's try and do 324 times 7. It starts off the same as before. We start with 7 times 300 to get 2100. Then we do 7 times 20, which is 140. Add those together to get 2240. But notice that we added those together before we took the third step of doing 7 times 4. So I've got 2240. Now I add 7 times 4, which is 28. 2240 plus 28. Go ahead and say the 2200 if you will. 40 plus 28 is 68. And there's your answer, 2268. That was hard the first time, I know. Let's do another example. Here's a question. How many days occur in a 6-year period? All right, so we'll start by doing the problem 365 times 6. Okay, so what do? We start with 6 times 300, which is 1800. Now, folks, another virtue of working from left to right is that we now know that our answer is a little bigger than 1800, right? I mean, if I were doing this problem from right to left, all that I'd know is that my answer ended in 0. But by working left to right, I know that my answer is a little bigger than 1800. And it's way more important to know that you have an answer that's a little bigger than 1800 than to know that your answer ends in 0. So by working from left to right, we're working with the most significant digits right from the start. Okay, but let's get the exact answer anyway. Next we'll do 6 times 60, which is 6 times 6 is 36, so 6 times 60 is 360. Okay, now at this point you want to stop and add 1800 plus 360. 1800 plus 360 is 2160. Good. Next we do 6 times 5, which is 30. Add those numbers before you forget them. 2160 plus 30 is 2190. And that's the answer. Well, actually, that's the answer to the multiplication problem. For the original problem, we'll have to add 0, 1, or 2, depending on the number of February 29ths among those 6 years. By the way, as we'll see later, you can get 0 leap years in a 6-year period when covering a year like 1800 or 1900. Anyway, you've now seen everything you need to know about doing 3-digit by 1-digit multiplication. Naturally, some problems are easier and some are harder, but the basic idea is always the same. We calculate from left to right and add numbers as we go. Let me give you a few more problems. I'll start with an easy one, and then we'll work our way up to some harder ones. All right, this one's very easy. Try to do the problem 402 times 9. Okay, so we'll start with 9 times 400, which is 3,600. Go ahead and say the 3,600. You can say it because all you're going to be left with is 9 times 2. So that 3,600 can't possibly change. 3,600. Next we do 9 times 2, which is 18. Say the 18 and you've said your answer, 3,618. Another good reason to work from left to right is that you can often, just like in this problem, you can often say your answer while you're still calculating. Not only does that help your memory do the problem, it also gives the illusion that you're doing the problem even faster, and that's a good thing. Now, what made this problem most convenient was that juicy 0 in the middle of the problem. Sometimes having a 1 in the middle of the problem also makes things easier, like in this next problem. Let's try 812 times 3. We start on the left with 3 times 800, which is 2,400. Now go ahead and say the 2,400. I know that 3 times 12 is going to be under 2,400, is going to be under 100, so I can say 2,400. Next we do 3 times 12, which is 36, and there's your answer, 2,436. Here's another problem where you can say the beginning of the answer without any risk of having to correct yourself. It's when we have the number 5 interacting with an even number. Let's do 527 times 8. So here we have 8 times 500, which is 4,000. Go ahead and say the 4,000. There's no way that what comes next is going to make that 4,000 change into a 5,000, right? Because what comes next is always less than 99 times 9. That's less than 100 times 10. That's less than 1,000. So you can safely say 4,000. Get it out of your memory. Now you do 27 times 8. Now that's a 2-by-1 problem. We've simplified our life to a 2-by-1 problem. 8 times 20 is 160. 8 times 7 is 56. 160 plus 56 is 216. And there's your answer, 4,216. All right, here's another easy one. Let's do 925 times 8. All right, so we'll start with 8 times 900, which is 7,200. Now, what's coming next after the 7,200? You can't say the 7,200, but look what's coming next. 25 times 8. Now, I happen to know that 25 times 8 is 200, right? If I've got 8 quarters in my pocket, I know that that's $2. And if you know something, don't be afraid to use it. 8 times 25 is 200. Add that to the 7,200, and you have 7,200 plus 200 is 7,400. Okay, let's try a harder problem. Let's try 789 times 7. All right, so we start with 7 times 700, which is 4,900. 7 times 80 is 560. Add those together from left to right. Listen to the numbers. 4,900 plus 560 is 5,460. Next we do 7 times 9, which is 63. We're going to have to do 5,460 plus 63. Now don't panic. What you can notice right now is that there's going to be a carry. So relieve your memory by saying 5,500 right now. That 5,400 becomes a 5,500. Now do 60 plus 63. That's as easy as 1, 2, 3, 123. So you know how the answer ends with 23. So there's your answer, 5,523. But there was another way of doing that last problem, 789 times 7, that you might find easier. Notice that 789 is 800 minus 11. Because of that, we could do this problem as 7 times 800 minus 7 times 11. 7 times 800 is 5,600. And now we have to subtract 7 times 11. 7 times 11 is 77. What's 5,600 minus 77? You know it's going to be 5,500 and something. 5,500 and what? Well, the complement of 77 is 23. So there's your answer again, 5,523. As we've seen before, we've taken a hard addition problem, one that had lots of carries, and turned it into an easy subtraction problem. Once you've mastered 2-by-1 and 3-by-1 multiplication, you can actually do most 2-by-2 multiplication problems, 2-digit times 2-digit numbers, using what I call the factoring method. Most 2-digit numbers can be factored into smaller numbers. As a matter of fact, 69 of the 92-digit numbers, more than 2/3 of them, can be factored into smaller numbers, and we can often take advantage of this. For example, consider the problem 23 times 16. Now, when I see 16, I can't resist thinking of 16 as 8 times 2. So for me, when I do 23 times 16, I want to do 23 times 8 times 2. So that's going to be our strategy. First multiply by 8, then multiply by 2. You can even hold that 2 on your fingers on reserve if that helps you remember it. Okay, let's do 23 times 8. All right, 23 times 8, that's a 2 by 1. 8 times 20 is 160. 8 times 3 is 24. 160 plus 24 is 184. Good. Pause. Take a break. You're halfway there. What do we do with that 184? We multiply it by the 2 you were holding on to, right? 184 times 2. If I double 184 or use the 3 by 1 methods we've learned, we get 184 times 2 is 368. So our original problem, 23 times 16, is 368. By the way, the reason that 23 times 8 times 2 is the same as 23 times 8 times 2 is due to what's known as the associative law of multiplication. But let me show you another way to do 23 times 16. I said 16 is 8 times 2. You could also say that 16 is 2 times 8. The same thing? Not really, because 23 times 16 we could now do as 23 times 2 times 8. Maybe you'll find that easier. 23 times 2 is 46, and when you multiply that by 8, 46 times 8 is 320 plus 48 is 368. This way you didn't have to do any 3 by 1 multiplication. Or maybe you'd rather think of 16 as 4 times 4. 23 times 16 is 23 times 4 times 4. 23 times 4, that's a 2 by 1, 80 plus 12 is 92. When you multiply that by 4, we have 360 plus 8, we get 368. Okay, let's do another problem. Suppose that your phone service costs you $59 per month. How much will that cost in a year? All right, so we can break up the number 12 lots of different ways. Let's break it up as 6 times 2. So we'll do 59 times 6 times 2. So we do 59 times 6. What's that? That's an easy 2 by 1. It's 300 plus 54, 354, and now we multiply that by 2. 354 by 2 is a not too bad 3 by 1 problem, because 2 times 350, do that all at once, is 700. And 2 times 4 is 8, so there's your answer, $708. One last problem. Suppose a swimming pool has dimensions 14 feet by 14 feet by 7 feet deep. What's the volume of the pool? Okay, well, the answer, of course, is 14 times 14 times 7 cubic feet. Let's do that multiplication in our head. Starting with 14 times 14, which we'll do a few different ways. One way of doing that problem, 14 times 14, is to break 14 into 2 times 7. So now you have 14 times 2 times 7, which is 28 times 7. And 28 times 7, that's 140 plus 56, is 196. Another way of doing 14 times 14 is you could do 14 times 7 times 2. 14 times 7 is 98. And when you double 98, you get 196. Or we can use the method we learned in Lecture 1 for multiplying two numbers between 10 and 20, right? We're doing 14 times 14. Let's not forget what we learned in Lecture 1. We can do that by taking 14 plus 4, which is 18, multiplying that by 10 to get 180, then add to that 4 times 4, 16, to get 196. Okay, so the original problem, 14 times 14 times 7 becomes 196 times 7, which we can also do in a few different ways. Using the addition method, we can do 196 times 7 by doing 7 times 100, 700, 7 times 90, 630. Add those together to get 1,330, then do 7 times 6, 42, add those together, 1,330 plus 42 to get 1,372 cubic feet. Or you could do it by subtraction. You could take 196 times 7 and take advantage of the fact that 196 is 200 minus 4. 7 times 200 is 1,400. Subtract 7 times 4. 1,400 minus 28 is 1,300 and what? The complement of 28 is 72, so there we have it again, 1,372 cubic feet. To summarize this lecture, I've shown you everything you need to know to do 2 by 1 and 3 by 1 multiplication, which are the most fundamental operations of mental multiplication. For most of these problems, you'll use the addition method, but sometimes you may find it faster to use subtraction. With just a little bit of practice, you can do any 2 by 1 or 3 by 1 problem in just a few seconds. And now would be an excellent time to practice. With these skills under your belt, you can even multiply most 2-digit numbers together. We'll have plenty more to say about mental multiplication techniques in this course, but before we do that, we'll attack the 4th of the fundamental operations of arithmetic. So get ready to divide and conquer.